Welcome to the third lecture of this course. In this lecture, we will explore the in-depth working of Cisco Firepower's Intrusion Prevention System (IPS). Before starting, one thing that I need to emphasize on is that the most of the features of Cisco Firepower are managed by the Snort engine. So it is important to study the architecture of Snort in order to understand the working of different modules of Cisco Firepower. The flowchart shows the major components of Snort architecture. These are packet sniffer, packet decoder, preprocessors, detection engine, and output module. The packet sniffer reads the packets using the data acquisition library and passes on the data to packet decoder. The packet decoder decodes the data link, network, and transport protocols and hands over the decoded data to preprocessors. The preprocessor is the most important component in the Snort architecture. This component normalizes the traffic and converts it into a readable form for the detection engine. The detection engine uses Snort rules to create signatures for threats and passes the data to the last module called the output module. The output module handles the task of writing and displaying the events. In order for packets to be inspected in a contextually relevant way, some further processing must be performed on them to reveal the context in which the packets are intended to be used. For example, are the packets part of a TCP communication? And if so, what protocol is being utilized? Are the packets fragmented? And if so, can they be correctly reassembled prior to inspection? Are packets identified as belonging to a particular protocol being used within the parameters of that protocol correctly? This is a sampling of some of the things that must be done so that the packets are presented in a contextually relevant way. Snort preprocessors handle this task. They are specially designed to put the network traffic into context for presentation to the other elements of the Snort architecture. This flowchart shows the flow of packet through the network preprocessor. The packet stream enters the IP defrag module, which defragments the IP packets and generates events as needed. Then the data goes into the TCP stateful inspection module or UDP session tracking module, depending on the protocol being used by the data. The TCP stateful inspection module verifies that TCP packets are part of an established session and generates events as needed. The UDP session tracking module also does the same for UDP traffic. The TCP packets then enter the TCP stream reassembly module, where the TCP streams are reassembled for more appropriate inspection events as needed. In the end, the traffic enters the application layer decoders, which normalizes the traffic and generates events as needed. The final stage is the rule execution, which is done by the Snort's rules engine. The detection engine accepts the parsed, normalized, and stream reassembled network traffic for inspection against the rule base. This component of the Snort architecture actually has two components to perform the action of inspection. First is the rules binder, second is the inspection against the built rules. On startup, the Snort Rules Builder goes through all the rules files to review the rules and reassemble them in such a way that inspection is optimized and redundancies in terms of sources, destinations, and port sources and destinations are not replicated in the construct against which network traffic is being evaluated. Chains of rules are built. Network traffic inspection takes place against the rule chains constructed during the build process. Snort rules have a fairly simple structure as defined below. Rule header. This portion provides the basic information regarding where a packet came from, where it's going to, what to do if a match occurs, and the protocol on which the rule should match. Rule options. This portion of the rule provides information on what specifically to look for in a packet payload or certain header fields to trigger a match. For example, the options for a given rule may trigger a match on the occurrence of a particular string as defined by the content option. If you observe this flowchart and the previous one, you will notice that both are the same, but this time we are going to study the flow of the packets through the SNOT architecture. The first step is the packet sniffing. Next up is the packet decoding, then pre-processing. Pre-processing determines many parameters of the traffic passing through it and classifies the traffic based on the protocols, applications, URLs, etc. Then the snort detection engine comes into play and selects the appropriate rules in light of the information received from the preprocessor in the previous step. And finally, the file is processed. The CN is taken on it to allow or block or any other rule that has been set for that particular kind of file. So with that, we have reached the end of this lecture. I hope the working of the intrusion prevention system module of Cisco Firepower is clear to you. Next up, we'll see the other modules of Cisco Firepower.